Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to lesson 28. This is properties of parallelograms. Okay, so we're moving away from triangles and we're going to get to parallelograms. So lesson 28, here we go. This is the first lesson in topic E. Opening exercise. So that means try it on your own, pause the video, see if you can do this, and then come back and see if your answers match mine. Okay, so opening exercise says, if the triangles are congruent, state the congruence. So I look at this and I say, okay, AG is congruent to YM. That is a side, but I see a right angle here, so I'm going to call it a leg instead of a side. And then I have a right angle and I have a right angle. Whoops, right there. So I've got an angle and it is a right angle. So AT is parallel to JM, Y is perpendicular to JT, AG is perpendicular to JT as well. They're parallel. So this is a transversal going through two parallel lines. Here's a parallel line, here's a parallel line, okay? So if I have, so I can't use hypotenuse leg here. I don't have any proof that AT is congruent to JM. They're parallel, that doesn't mean they're congruent. So if I do this, let me change the color. That is my transversal. When I have a transversal, alternate interior angles of the parallel lines are congruent. So I have angle, angle, side. So angle, angle, side. So I will call this a side, not a leg. So it's angle, angle, side, angle, angle, side. So therefore it is a congruence. So let me get that out of the way so I can see the names, and now I will name them. State the congruencies. Well, triangle AGT is congruent to triangle MYJ. By angle, angle, side. Okay, I didn't ask that, but why not? Oh, and look at here. Which triangle congruence is it? Okay, it does ask. So AS. Part C, TG corresponds with, so let me erase all this mess. So TG, where's TG? Okay, so I'm just going to shorten this red line now, and that's what they're talking about. TG, what does that correspond with? And make sure you name it correctly. TG corresponds with JY. So if I'm saying T first and G second, and G's my 90-degree angle, and I can't say YJ. It's got to be JY. So TG corresponds with JY. YJ would be incorrect. Discussion. How can we know? How can we use our knowledge of triangle congruence criteria to establish other geometry facts? For instance, what can we prove about the properties of parallelograms? To date, we have defined a parallelogram to be a quadrilateral in which both pairs of opposite sides are parallel. However, we have assumed other details about parallelograms to be true too. We assume that opposite sides are congruent, opposite angles are congruent, diagonal bisect each other. Let us examine why each of these properties is true. Okay. Okay, page 2 brings us to our first example. Example 1, page 2. If a quadrilateral is a parallelogram, then its opposite sides and angles are equal in measure. Complete the diagram and develop an appropriate given and prove for this case. Use triangle congruence criteria to demonstrate why opposite sides and angles of a parallelogram are congruent. Okay, so if it is given, then we say parallelogram and we need to name it. So I'd say given parallelogram and let's just call it A, B, C, D. Given parallelogram A, B, C, D, opposite sides are congruent. So A, B is congruent to DC. Let me name this first, okay? I want to explain something as I do this. So if I'm going to call this A, B, C, and D. A is obtuse, B is acute. Obtuse to acute, so I'm going to say, if I'm going to say AB, that's saying obtuse to the acute angle. I have to go obtuse to the acute angle here, so it's not DC, it's CD. So label your diagram before you try naming these things, because DC would be incorrect. AB is congruent to CD, and AD is congruent to CB. Okay? And angles are equal in measure. Okay, so it says to prove what? Complete the diagram and develop an appropriate given and prove for this case. Use triangle congruence criteria to demonstrate why opposite sides and angles of parallelograms are congruent. Okay, so we want to prove, I can't say congruent, that's what we're trying to prove. So my apologies here. Let me go really small there so I can get this out of here. I want to prove that they're congruent. What I'm going to say though is, since it is a parallelogram, AB is parallel to CD and AD is parallel to BC. So that's our givens. We're trying to prove. So there's our little diagrams showing parallel sides. And what else does it say? Opposite sides and angles are equal in measure. So we want to prove the then. So if quadrilateral is a parallelogram, then its opposite sides and angles are equal. So if we have an if-then statement, we're trying to prove the then portion. So I have to prove that AD is equal to BC, CB, CB, comma. I have to prove that AB is equal to CD. I have to prove that the measure of angle A is equal to the measure of angle C, and I have to prove the measure of angle B is congruent. Am I going to say, no, I'm saying measure, so it's equal. Measure of angle B is equal to the measure of angle D. Those are the four things I want to prove. Opposite sides are congruent, opposite angles are congruent, or equal in measure. Construction, label the quadrilateral ABCD and mark opposite sides as parallel, which I have done. Now it says to draw a diagonal BD. So I will do that. How about in blue? So there's our diagonal. Let me fix that a little. Okay, close enough. Okay, so now I need a proof chart table. Okay, so here we go. Statement reason table. The first thing we want to say that ABCD is a parallelogram. So just say, what in the world? Parallelogram ABCD given. So we're saying ABCD is a parallelogram given. The measure of angle. Now we're talking about the angles. The diagonal is really going to help us here, because now we've broken it into two triangles and we now know how to prove triangles congruent, don't we? So triangle A, or angle ABD is congruent to angle CD. So angle ABD, the measure of angle ABD equals the measure of angle CDB, because they're alternate interior angles. Okay, so what you would say is if parallel lines are cut by a transversal, then alternate interior angles are congruent. I'm just going to shorten that by just saying alternate interior angles congruent. Okay. Okay, so now we have one angle to one angle. We have a shared side, don't we? BD is in both triangles. So now I can say BD equals BD. Okay. Reason, reflexive property. Okay, so now we have this side congruent to itself. Okay, again, alternate interior angles right here and right here. They're also alternate interior angles because we have two sets of parallel lines. Now if BC and AD are my parallel lines, then the BD is a transversal. These are alternate interior angles to the other sides. So now I can say the measure of angle CBD, and let's start with ADB. ADB is equal to the measure of angle CBD. And again, alternate interior angles are congruent. Okay, now I can say triangle ABD is congruent to ABD is congruent to CDB. What you name the first triangle doesn't matter, but these pieces have to correspond. Okay. Now I can say this side is equal to this side. So now I can say AD is equal to CB. Oh, by the way, this was angle, side, angle. I didn't give the reason here. It's ASA. And this is corresponding parts of congruent triangles are congruent, or corresponding sides of congruent triangles are congruent. So now I know AD is equal to CB. Okay, I can now say the measure of angle A is equal to the measure of angle C. And that's also corresponding angles of congruent triangles congruent, or corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay, so now I can say the measure of ABD, the measure of angle ABD plus the measure of angle, so ABD is here, plus the measure of angle CBD equals the whole thing, ABC, the measure of angle ABC. So all I'm saying here is that this angle here plus this angle here equals the whole thing. Okay, and the reason for that is angle addition postulate. Angle addition postulate. Let me scroll up a little here. Okay, so now we have this angle here. So we have, and we're going to do the same over here. The measure of angle ADB plus the measure of angle CDB equals the measure of angle, the whole thing, ADC. And that is also angle addition postulate. Okay. All right, so now I'm going to say angle ABD plus CBD. So all I'm saying now is this is going to be equal to this. Okay, so now I'm just going to state that the measure of angle ABD plus the measure of angle CBD equals the measure of angle ADB plus the measure of angle CDB. And the reason? Angle addition property of equality. Okay, so all I'm saying is if these two equal ABC, so what I'm really saying now is the green pair equal this, the red pair equals, oh, I don't want to use red, I've already used red, how about orange? This. Well, ABC, angle ABC is equal to angle ADC. Because ABD plus CBD equals ADB plus CBD. So if these two are equal, then the measure of angle B equals the measure of angle D. And I'm going to get to explaining that in a second. The measure of angle B equals the measure of angle D. And the reason for that is substitution. Okay, let's recap what I just said. All right, so we said that ABD plus CBD equals ADB plus CDB, because if these pieces are congruent, so if this was 40 and that was 40, and this was 60 and that was 60, 40 plus 60 equals 40 plus 60, 100 equals 100. So now when I say the measure of angle B, well, I look here, there's more than one angle B. There's an ABD and there's a CBD at B. When they're talking measure of angle B, they're talking about the parallelogram. So if I were to now get rid of this transversal that we used to prove all of this and got rid of all these marks down here, now we're back to the parallelogram, and now we just proved that angle B is congruent to D. Angle A was congruent to C, which is right here. B congruent to D is right here. So that's here and here. We said that AD was equal to CB, and we said that AB, or did we? We haven't said that yet. AB equals CD. Okay, so we need to say AB equals CD. We haven't done that yet. I can put it right here because it's the same reason. So I said AD equals CB, corresponding parts congruent, triangles congruent. And I could also have said right there, AB equals CD as well, for the same reason. Okay, if I put my transversal back because of the corresponding parts of congruent triangles. So there we have proved opposite sides are congruent. We've proved the measure of the opposite angles are congruent or equal. Okay. Okay, page 3 brings us to example 2. All right, so here we go. If a quadrilateral is a parallelogram. Okay, so given we have a parallelogram. Just out of habit, I always just name it alphabetical order A, B, C, D. Okay. Then, so if is our given, then is what we're trying to prove. Okay, does that make sense? So we're trying to prove diagonals bisect each other. What does bisect mean? Okay, cut into two congruent pieces at the midpoints. So I'm going to name my quadrilateral A, B, C, D. When you're naming a parallelogram or any figure, always go either clockwise or counterclockwise. I prefer clockwise. Okay, let me give you an example that is not an example of what not to do. A, B, C, D. Never do this, because if you drew a line to the letters that, as you named it, A, B, C, D, see what it did? You created a Z. You don't want to cut through the diagram. What you want to do is just A goes to B, B goes to C, and C goes to D. It's like rounding bases in a baseball game, except we're going clockwise in this case. Baseball's counterclockwise. Okay, we can go counterclockwise though, as long as you go in order. Okay, with that said, let's continue, complete the diagram and develop an appropriate given and proof for this state case. Given and proof, I guess. Use triangle congruence criteria to demonstrate why diagonals of a parallelogram bisect each other. Remember, now that we have proved opposite sides and angles of a parallelogram to be congruent, we are free to use these facts as needed. For example, AD is equal to CB. AB is equal to CD. Angle A is congruent to angle C. Angle B is congruent to angle D. So what we just did on that last page was really a powerful thing that we brought over from our triangle information. So as you can see, everything builds upon itself. And as soon as you've proven something one place, that is now in your arsenal, if you will, your book of usable tools. Okay, and that's what they're basically saying there. So they say diagonals will bisect each other. Let me draw the diagonals. And I'll draw them in red. So there's diagonal AC. I'll fix that in a moment. And there's diagonal DB or BD. Okay, so there are our two diagonals. What we're trying to prove, and I'm going to call this E right here. I'm going to try to prove AE is congruent to CE and BD is congruent to DE. Okay, so that's what we're trying to prove. Diagonals bisect each other. In other words, what I just said, let me leave it green, AE equals CE. All right, so AE equals CE, and we want to prove that BE equals DE. Okay, that's what we're trying to prove. Construction. Label the quadrilateral ABCD. Mark opposite sides as parallel. I've done that. Oh no, I haven't. Draw diagonal AC and BD. That's done, but I got to mark the parallels. But let me bring in my table. Okay, so here it is, and here we go. So the first thing we want to say is our given. Let me use blue now just to brighten things up. Okay, we're given that parallelogram ABCD. Okay, so we know ABCD is a parallelogram. I need to label, I'm going to use blue. This is parallel to that. This is parallel to this. Okay, because it said mark opposite sides as parallel. Draw diagonals AC and BD, which I've done. Okay, now let's go. The measure of angle BAC the measure of angle BAC is equal to measure of angle DCA. That's what we're going to start with. The measure of angle BAC, that's this, is equal in measure to the angle DCA. Okay, and that's because we have a parallel line cut by a transversal alternate interior angles are congruent. Okay, that's a period there, that's an I. Sorry for the mess. Okay, so those are congruent because alternate interior angles are congruent. So now I can say the measure of angle AEB, see this one right here, the measure of angle AEB equals the measure of angle AEB, that would be CED. And those are vertical angles. Vertical angles are congruent. Okay, so now I have this angle and this angle congruent. And now I can say AB equals CD, right? Because it's a parallelogram, opposite sides are congruent. We proved that on the last page. So now I can use that. Side AB is equal to side CD. Okay. And the reason is opposite sides of a parallelogram are congruent. So I use this little symbol here for parallelogram. Opposite sides of parallelogram are congruent, ABCD. Okay, so now I can say triangle AEB is congruent to triangle CED. Reason, angle, angle, side. Okay, so now I can say AE equals CE. And that's corresponding parts of congruent triangles are congruent. So once you have the triangle, then you use that corresponding parts thingy. And we can also, let's just put it all in the same line, DE. So I said AE equals CE. BE is equal to DE. And that's what we were trying to prove. And they're both, because of corresponding parts of congruent triangles, are congruent. So we just proved that this equals this and this equals that because of the corresponding parts of the angle side prove triangles are congruent. Okay, I never labeled that vertical angles. All right, so as we go, we have more tools in the toolbox to prove things, and it makes our proofs actually easier. Okay. Okay, page, what are we on? Page 4. Page 4 brings us to example 3, but before, let me read this. It says, now we have established why the properties of parallelograms that we have assumed to be true are in fact true. By extension, these facts hold for any type of parallelogram, including rectangles, squares, and rhombuses. Let us look at one last fact concerning rectangles. We established that the diagonals of general parallelograms bisect each other. Let us now demonstrate that in a rectangle, they have congruent diagonals as well. So example 3 says, if the parallelogram is a rectangle, so when you see if, that is our given. So you say we have a rectangle. Parallelogram is a rectangle. All rectangles are parallelograms, but not all parallelograms are rectangles, right? Right. So rectangle Since a rectangle is a parallelogram, it shares the same properties as a parallelogram, and then some. So we have a rectangle. What are we going to name it? Well, if I see down here, construction, label the rectangle GHIJ, that tells me to name this GHIJ. Okay, so given rectangle GHIJ. See what it says? Label it. Make opposite side, mark opposite sides as parallel. So GJ is parallel to HI. GH is parallel to JI. Add a small square to the vertices to indicate a 90-degree angle. So J is 90 degrees, G is 90 degrees, H is 90 degrees, and I is 90 degrees. That is the difference between a parallelogram and a rectangle. Parallelograms, opposite angles are congruent, but they're not necessarily 90 degrees. But in a rectangle, they're 90. So the then is what we're trying to prove. Diagonals are equal in length. In other words, GI is going to be equal to GI is going to be equal to IH. No, silly, that's not a diagonal. GI is going to be equal to HJ. Yeah, that's it. Yeah, HJ. Okay, GI, HJ. So let me draw those. Okay. Okay, there they are. So it says to label the rectangle GHIJ, mark opposite sides as parallel. We've done that. Add small squares. We've done that. Draw diagonal GI and HJ. We've done that. Statement. Here we go. How about I switch to my pen? Okay, so we're going to say rectangle GHIJ. Given. Okay, we have a rectangle. Fantabulous. Okay, now we're going to say GJ. All right, so before I go on, I'm going to change the colors of these diagonals. I'm going to change this to red. Okay, and there's a reason I'm doing this. I'll show you what triangles we're going to use to prove congruence. Something happened to my red. I did something wrong. All right, so there's that. And then I'm going to choose this. I'm going to make it red. And then I'm also going to draw a red triangle. Okay, see what's going on here? So we have two triangles, one red and one blue, and that shares one leg. That's how we're going to solve this or prove it. Okay, so now I'm going to say GJ is congruent to IH. Why? Opposite sides of a parallelogram are congruent. Okay? Opposite sides of a parallelogram are congruent. Then I'm going to say GH is equal to itself. And that is the reflexive property. Okay. Angle JGH okay? And angle IHG are right angles. Okay, and because that's a definition of a rectangle. So now I have this is a right angle, and this is a right angle. So I have two right triangles. This blue triangle and this red triangle are right angles, right triangles. Side congruent to a side, included angle, shared side. The triangles are congruent by side, angle, side. So I'm going to say triangle JGH is congruent to triangle IHG. Let me fix that. That's messy. Reason? SAS. Okay. Now that I have proved that, I can now say GI is equal to HJ. Corresponding sides of congruent triangles are congruent. Okay, so now we can use that diagonals are congruent in rectangles to prove other things, okay? So that is the new tool that we can add to our toolbox. Okay, page 5 brings us to converse properties. Now we examine the converse of each of the properties we proved. Begin with the property and prove that the quadrilateral is, in fact, a parallelogram. So keep in mind that a converse is the opposite direction of a conditional statement. So you said, if you say, if it's Monday, then I go to school. The converse to that would be, if I go to school, then it is Monday. Okay. The first is true, the second could be true, but it could also be false. So converse is just if P then Q turns into if Q then P, if you will. So anyway, here we go, example 4. If both pairs of opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. Draw an appropriate diagram to provide the relevant given and prove for this statement. All right, so let me first start off by what we've been doing. If is our given. So we're given a quadrilateral, and then I come down here and I look at its name, A, B, C, D. So we are given that quadrilateral. A, B, C, D. We're given a quadrilateral. Okay. And we're told that opposite angles are congruent. So let me label this thing up and A, B, C, D. Opposite, okay, it says if both pairs of opposite angles of a quadrilateral are equal. In other words, if A, the measure of A equals the measure of angle C, and the measure of angle B equals the measure of angle D. I'll put it above, I'm running out of room. Okay, there's our givens. Okay. What we're trying to prove is the then. So let me underline that. So we're getting in the habit of doing this. Okay, and I'm picky about this in class, so I should be picky about it here. The if word and the then words are not part of your hypothesis and conclusion, okay? The conclusion is not then the conclusion is the quadrilateral is a parallelogram, okay? So we're trying to prove quadrilateral A, B, C, D is a parallelogram. I'm just going to use this symbol here for parallelogram to save space. Okay, so now we're going to do a construction of this. So I've already marked the angles. It says label the quadrilateral ABCD, mark opposite angles as congruent. Done. Draw diagonal BD. Let me fix that a little bit. All right, close enough. Okay. So I did what they asked me to do. Label measures of angle A and angle C as X degrees. Pretty easy so far, right? Just following directions. All right. Label the measures of the four angles created by BD as R, S, T, and U. So this is going to be R degrees, S degrees, T degrees, and U degrees. Okay, so we've done all of the labeling that they asked us to do, and now we're going to construct the proof. So let me get my table. Okay, here we go. So first thing we do is list our givens. So I'm just copying this quadrilateral. ABCD with angle B equals angle D and angle A equals angle C. Okay, actually I should have a little measure thingy there. The measure of, let me rewrite that, that's a mess. The measure of angle A equals the measure of angle C, comma, measure of angle B equals measure of angle D. And a big old given. Okay, for both of those. Okay, so what does D equal? Well, the measure of angle D equals R degrees plus S degrees. And also the measure of angle B equals T degrees plus U degrees, correct? R plus S is all of D, T plus U is all of B. Okay, and that's just angle addition. Okay, so if D is equal to B, which we already knew, then now we can say R degrees plus S degrees equals T degrees plus U degrees. Okay, and that's substitution. Okay, let me move this up a little. Okay. We have triangles now, don't we? And the sum of a triangle is 180 degrees. So now I can say X plus R plus T is triangle ADB. So I can say X degrees plus R degrees plus T degrees equals 180 degrees. And that's triangle sum theorem. Angle is a, okay, triangle sum theorem, I call it. Okay, or you could say angles in a triangle add up to 180. Alrighty. So if r plus s equals t plus u, and x plus r plus t equals 180, we can also say x plus s plus u equals 180. So these two things are because of the triangle sum theorem. I did it in both triangles, okay? So now that we have these x's, okay, so if we ignore those, we have r plus t equals 180 minus x, s plus u equals 180 minus x. It's not ignoring them, it's moving the x to the other side. 180 minus x, x has to be the same in both equations. 180 minus x equals 180 minus x. So r plus t is equal to the same thing as s plus u. So now I can say r plus t is equal to s plus u. Okay. And that is subtraction property of equality or substitution. I'll just put substitution because it's less to write. Substitution. So r plus t equals s plus u. Okay, what are we going to do with that? Okay. R plus t, r minus s, r plus s. Okay. If I do this, okay, this angle plus this angle, and I subtract these two, what's that going to do? R plus t minus r plus s equals s plus u minus t plus u. Okay, let me move that over so it's so r plus t minus this whole thing, which is d, is going to be the same as taking s plus u minus t plus u, which is all of b. Okay, so r plus t minus d, which is equal to b, would be the same as t plus u minus b, because we already know that r plus t is equal to s plus u from here. So if r plus t is here and s plus u is here, and we subtract r plus s from one and t plus u from the other, well, r plus s and t plus u is all of d and all of b, and we already know they're congruent, so we're subtracting the same values from r plus t and s plus u. Whew, that was crazy. That is the subtraction property of equality. Okay. So if I simplify this, let's see. If I take t and subtract s, that would be the same as saying s minus t. Okay. Let me think here a sec. Okay, so that's the additive inverse. So t minus s is the same as s minus t because t and s are congruent. Remember, this is a quadrilateral and we have alternate interior angles because that's a diagonal. Okay. But we can't say it's a parallelogram yet. We're saying it's a quadrilateral. Anyway, t minus s equals s minus t is the additive inverse property. So now if I take t minus s and add s minus t, that is going to equal s minus t and adding t minus s. No, s minus t, same thing. We're adding the same thing to both sides. So first we're saying t minus s is equal to s minus t. So t minus s plus s minus t is the same as s minus t plus s minus t. Okay, since t minus s and s minus t are equal and you add the same thing to equal things, they're still equal. Okay, so that is the addition property of equality. Okay. So t minus s plus s minus t is 0. And that equals s minus t plus s minus t is 2 s minus t's. Okay, so now we're bringing in some algebra here. So if I divide both sides by 2, 0 divided by 2 is 0. 2 divided by 2, if I divide this by 2, the 2 cancels and I get s minus t equals 0. Okay, well, if s minus t equals 0, then s has to equal t. And I will give the reasons for all these as we go. I'll go back up. So 0 equals s minus t, that's the division property of equality, or addition and subtraction properties of equality. So this is addition and subtraction properties of equality. Okay, because we added, subtracted, whatever. And then division property of equality, we divided both sides by 2. Okay, so if 0 equals s minus t, then you can add t to both sides and s is equal to t. That's the addition property of equality. Okay. So now I can say if s equals, if s equals t, then we can conclude if s equals t, then r has to equal u. Okay, and that's substitution and subtraction properties of equality. Okay, so we know s equals t, r equals u, because if s is equal to t and s plus r equals t plus u, then r has to be equal to u. That's from up here. So that's why we are saying r equals u. Okay, so now if S equals T and R equals U, that would be, let me do it in blue, S equals T and R equals U, then we have angle side angle. Okay, and then we can also say AB is parallel to CD. Okay, we have a transversal and we have alternate interior angles are congruent. Okay, so we aren't proving these triangles are congruent because we don't know that this was a parallelogram. That's what we're leading up to. But now that we say that T is equal to S and R is equal to U, and we have this line here and then A, B, and DC, these have to be parallel because T cannot equal S. If a transversal cuts two lines that aren't parallel, then the alternate interior angles are not congruent unless they are parallel. So now we have just finally come to the conclusion that AB is parallel to CD. And also AD is parallel to BC because, again, we have a transversal and R is equal to U. So now I can say AD is parallel to BC. Reason, two lines cut by a transversal, blah, blah, blah. Alternate interior angles are congruent. Okay, let me just clean this up a little. Okay, now we can say quadrilateral ABCD is a parallelogram. Reason, definition of parallelogram. Okay, that was a long proof. Hopefully you followed along. A little bit of algebra in there too. Page 6 brings us to example 5. We have an if-then statement. So let me underline the hypothesis. The opposite sides of a quadrilateral are equal. That is our given. Okay, so we have a quadrilateral. Quadrilateral, and they're naming it ABCD, so I will name it ABCD. Opposite sides are equal, so I'm going to stop here. Label the quadrilateral ABCD. Mark opposite sides as equal. AD, DD, DD, DD. Draw diagonal BD. Okay, let me fix that a little. It's off by a smidgen. Okay, that's not bad. Okay, so there's our hypothesis, and our conclusion is the quadrilateral, keep it neat, the quadrilateral is a parallelogram. Okay, so quadrilateral ABCD is a parallelogram. Okay, so there's our given, there's our proof. Labeled the diagram, drew the diagonal. I need my table of, okay, so here's my table. Let's scroll up. And we are trying to prove quadrilateral ABCD is given. So we write given. Okay. All right, so now what do we do? We also want to say, I haven't said this yet, it says opposite sides are equal. So I want to say AD equals BC and AB is equal to CD. Okay, so I want to say that here, AB equals CD, comma, AD equals BC. And that's also given. Okay, so what are we trying to prove? Quadrilateral is a parallelogram. What's the definition of a parallelogram? Opposite sides congruent, opposite sides parallel, opposite angles congruent. Okay, so there's a bunch of stuff. All right, so we're going to first start off with BD is equal to itself. Reflexive property. Love the reflexive property. Okay, we're done proving triangles are congruent anyway. So now I can say triangle ABD is congruent to triangle CDB. Reason, SSS. Okay, side, side, side. Now that I know the triangles are equal, I can now say angle ABD is congruent to CDB. Not ABD, ADB, ABD. ABD is congruent to CDB. Reason? Corresponding parts of congruent triangles are congruent, or if you prefer, corresponding angles of congruent triangles are congruent. Okay. So with that said, I have alternate interior angles with alternate interior angles with a transversal. Therefore, we can now say AB is parallel to CD. And we can also say that AD is parallel to CB. CB. Okay. The reason, two lines cut by a transversal, alternate interior angles are congruent, then the lines are parallel. I'm going to bring that in because it's very lengthy. Okay, so if two lines are cut by a transversal and the alternate interior angles are congruent, which they are, then the lines are parallel. So I will label those as parallel. So this is parallel to this, and this is parallel to this. That's what this says. Okay, so now since they're parallel, I can now say quadrilateral ABCD is a parallelogram. And that's because it's the definition of parallelograms. And we're done. Page 7 brings us to example 6. If the diagonals of a quadrilateral bisect each other, stop. If, I said if I say if, I have a hypothesis. That's our given. If I don't want to write if, what am I doing? I just want to say we have a quadrilateral and it's called ABCD. We have a quadrilateral ABCD. And we have the diagonals bisect each other. So let's label it A, B, C, D. Mark opposite sides as equal. Draw diagonal AC. And BD. Okay, so there's the diagonals. Let me just move this a little bit. Okay. All right, so now I can name them. Quadrilateral ABCD, the diagonals bisect each other. So then I can say AC bisects BD. Actually, BD bisects AC. They bisect each other. Okay, that's our givens. So I'm going to copy that. So you can start writing, but I'm going to cheat. Quadrilateral ABCD. So I've got all these here. And all this is given. Okay. We haven't done the then portion yet. I haven't finished reading yet. That was just the hypothesis portion. Now we have a conclusion. The conclusion is what we're trying to prove. So quadrilateral ABCD is a parallelogram. Okay, quadrilateral ABCD is a parallelogram. Okay, just tried to make that a little bit neater. That's the symbol for parallelogram. Okay, so label the quadrilateral ABCD, done. Mark sides opposite equal, done. Draw diagonal AC and BD, done. Now let's begin our proof. Okay, so the first thing we want to do is the givens we've done. We want to say that we want to label our intersection E. This is E. Okay, so AE, we have a bisector. We're given that AE equals CE. Okay, and BE equals DE. Definition of segment bisector. Okay. Definition of segment bisector. So let me label those. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. AD equals BC, DC equals AB, AE equals CE, BE equals DE. Okay, so the measure of angle DEC equals measure of angle BEA. So now I'm going to say that this angle is equal to this angle. the measure of angle DEC is equal to the measure of angle, so I said DEC BEA. Reason? Vertical angles. Okay? We can also say that this angle here is equal to this angle here. So the measure of angle AED is equal to the measure of angle CEB for the same reason. Okay? So now I have triangle DEC. Triangle DEC is congruent to triangle BEA. And triangle AED is congruent to triangle AED, CEB. Okay? By side angle side, side angle side, side angle side, side angle side. So all of these are because of SAS. Okay. Now I can say angle ABD right here. Let me change, let me change colors. Let me make purple for this now. So angle ABD is congruent to CDB. And also, I can say angle ADB, okay, ADB is equal to CBD. Okay? Or they're congruent, I guess. If I don't say the measure of, they're congruent. So ABD is congruent to CDB, ADB is congruent to CBD. Okay? Corresponding angles of congruent triangles are congruent. So that is C, P, C, T, C. Okay, so let me label that. ADB is right here. Is congruent to CBD. Is right there. Okay, all kinds of congruencies going on here. So now I can say AB is parallel to CD. And AD is parallel to BC. And the reason is two lines cut by a transversal, alternate interior angles are congruent, then the lines are parallel. Okay, that's a lot to write, so I just brought in the text. And now that we have parallel sides, I'm going to label the diagram. Let me use purple's fine, I guess. So this is parallel to this, and this is parallel to this. And now I can say quadrilateral A, B, C, D is a parallelogram. Reason, definition of parallelogram. Whoops. Let me just copy this one. Come on, you. Hello. Pen's acting up. There we go. Definition of parallelogram. Page 8 brings us to example 7. If the diagonals of a parallelogram are equal in length. What word did I just say? If. That is a hypothesis. That is a given. Parallelogram. Parallelogram. GHIJ. Diagonals are equal in length. Label the diagram. Draw diagonal GI. Draw diagonal HI, HJ. Okay, there's our diagonals. Are equal in length. So now I can say, comma, GI equals HJ. Okay, getting the hang of this. So now we're going to look at our conclusion. Okay, so then we will say parallelogram GHIJ is a rectangle. That looks like area. Okay, that's what we're trying to prove. We're trying to prove this parallelogram is a rectangle. I made a statement earlier in this video. I guess I was ahead of myself. Okay, so, all right, we're going to copy this. Bring this down here. Statement reason. Okay, what's the reason for this? Given. Okay. So what do we have? GJ equals JG. So what are we trying to prove here? That this is a rectangle. How are we going to prove it is a rectangle? We're going to work with these two triangles over here. Okay, so the first thing I'm going to say is GJ equals JG. Okay, GJ is equal to itself. I'm also going to come over here and say HI is equal to itself, but I don't know they're equal to each other, so I use 2 marks. That is the reflexive property. Okay, then we're going to say GH is equal to IJ. Okay, why? Opposite sides of a parallelogram are congruent. Sorry for the messy writing. Opposite sides of a parallelogram are congruent. So now we have triangle HJG. So let me color code this so you can see what triangles we're working with. Okay, did I do that right? HJG. No, this should be blue. And this should be green. So not here. I want a segment over here. Okay. We said GH is congruent to IJ. We said GJ is congruent to itself. So with these two statements here, okay, I'm going to say that triangle HJG is congruent to, that's the blue triangle, IGJ, the green one. Okay, so the blue one is congruent because GH is equal to IJ, GJ is equal to itself, and we're given that the diagonals are equal in length. So this whole diagonal, GI, is congruent to the whole diagonal, HJ. So we have side, side, side. Okay, so blue's congruent to green is what we're saying here. But we're going to come back up here, and GH is equal to JI. I can also say, no, I'm just going to leave it at that for now. Now I'm going to say the measure of angle G is equal to the measure of angle J. Okay, right here. Because the triangles are congruent, the measure of angle G equals the measure of angle J. We can also say the measure of angle H is congruent to the measure of angle I. Well, I'm getting ahead of myself here. I haven't stated. Let's get back to that in a minute. G is congruent to J because G is the right angle in the blue triangle. J is the right angle in the green triangle. And the triangles are congruent. So that's corresponding angles of congruent triangles are congruent, or corresponding parts of congruent triangles are congruent. Okay, but getting back up here, I can now also say that triangle GHI, okay, that is going to be congruent to triangle. So I said GHI, that's right here. So let me draw that. Or let me, oh, yeah. I'm not going to draw, it's just going to get too messy. GHI is here. It's congruent to JIH. That's hard to read. Let me fix it. Okay, still a little bit going over that line, but GHI, congruent triangle JIH. Okay, they're overlapping this way. So they share side HI, congruent. JI is congruent to GH, and they are, GI is congruent to HJ. So then I can say that that's also congruent to each other by side, side, side. And so if I said the measure of angle G equals the measure of angle J, now I can say the measure of angle H is equal to the measure of angle I by the same reason. Whew, okay. Hopefully that didn't confuse you too much. Okay, so notice I marked these right angles. I'm ahead of myself there, but I'm just going to leave them there for now. I should have just put arcs there because I don't know they're a rectangle yet. We don't know it's a rectangle. So a parallelogram, we just know that these are angles, but we do know that the measure of angle G plus J, the measure of angle G plus the measure of angle J equals 180 degrees. Okay. We can also say that H plus I does the same. The measure of angle H plus the measure of angle I also equals 180 degrees. And the reason is, if parallel lines are cut by a transversal, then interior angles on the same side are supplementary. Okay? Parallel lines cut by a transversal, angles on the same side add up to 180. So that plus that equals 180. This plus this plus this equals 180. All right. Measure of angle G plus J. So G plus J equals 180. Two parallel lines, transversal, they're on the same side. Okay. I wasn't sure what I was looking at there. I was thinking of these transversals, but any line that cuts two parallel lines is a transversal. So GH is parallel to JI. Okay. And HI is a transversal. So this angle and this angle are interiors to the two parallels cut by transversal, so they add up to 180. Got it. Check. Okay, so then we're going to go to, since G equals J and H equals I, the measure 2 times the measures of G. In other words, if G equals J, G plus J is 180. So if I say 2 times the measure of angle G equals 180, and 2 times the measure of angle H equals 180 degrees. And that's the substitution property of equality. Where are we substituting that from? G equals J. G plus J is 180. If G equals J, then I can resubstitute in another G for J, so I could say G plus G, or 2G equals 180. Got it? Substitution. Okie dokie. All right, I can now say that the measure of angle G, the measure of angle G equals 90 degrees. I can also say the measure of angle H equals 90 degrees because I divided. So it's the division property of equality. Okay? Divide this by 2, divide this by 2, we get mg equals 180 divided by 2, or 90. Same with over here. Division property of equality. Now I can say the measure of angle G equals the measure of angle J. And the measure of angle H equals the measure of angle I. Okay? Because they're all equal to 90 degrees. And that's substitution again. Okay, and then finally, we can say GHIJ is a rectangle. Reason, definition of rectangle. Okay, and we are done. Okay, page 9 brings us to the end of lesson 28. Okay, proofs in small doses are okay, but I just did a whole bunch all at once. I'm tired. Go do your problem set.